Okay, so first we're going to be taking a look at alkenes, right? And so first we're going to start off looking at their structure and their formulas. Now the commonest alkene that I'm sure everybody knows or has heard about in class is ethene, right? And essentially alkenes are differentiated from other organic compounds by this carbon-carbon double bond. That's essentially what we would call their functional group. Alright, and so now this functional group here allows alkenes to take part in loads of reactions that basically alkanes, alkynes, alcohols, and etc. can't really take part in. So just going to be looking at some common alkenes just to jog our memories. So this first one here is ethene, as I'm sure we all know. Because of the 2 carbons, the prefix would be F, right? Then we'll look at propene. One, two, three, four. Propene. We call this propene or prop-1-ene. We won't really look at how to name them right now. We're just focusing on the basics. We can look at butene as well. 2, 3, 4. But-1-ene, we'd call this. Obviously, if the double bond, which is here, was placed here rather than here, then we'd call it but-2-ene. So far, so good. Alright, so now, compounds in general that have this carbon to carbon double bond right here, we like to call them unsaturated. Compounds that have a carbon to carbon single bond, things like alkanes now, for instance, we like to call them saturated. Right, so now that means, what does them being unsaturated essentially mean, guys? It means that they can make more bonds with other atoms by opening up this carbon double bond right here, right? And it basically allows incoming atoms to form a single bond, right? When we open this double bond up. What do I mean by us opening this double bond up? Okay, if we have ethene now here, and it undergoes a certain reaction that we will go over in about a minute, then what's going to happen is this double bond right here is going to open up and we're going to form ethane. We're going to revert back to a single bond. Perfect. Okay, and now each of these carbon atoms, as everybody knows, they form 4 single bonds instead of 1 double bond and 2 single bonds, and this property makes them much more reactive than alkanes. We know that carbon as an atom in general, for example in ethane now for instance, with hydrogens placed all around, both carbons are tetravalent in this case, in the sense that they need 4 they have 4 valence electrons, so they need to form 4 bonds. Just like in any hydrocarbon you're going to see with a carbon atom, all carbon atoms are tetravalent, so they have 4 valence electrons, meaning they need to form 4 bonds, whether it be 1 double and 2 single, whether it be 1 triple and 1 single, etc. Now we're going to take a look at the combustion alkenes, which is one of their famous reactions. So these compounds, the alkenes, they undergo both complete and incomplete combustion, but because of their higher carbon to hydrogen ratio, they tend to undergo incomplete combustion, meaning they produce, which basically means they produce like a smoky flame in the air. Smoky flame, right? But what would a complete combustion reaction entail? It basically entails the formation of water and carbon dioxide. So if we look at this example element here, butene, we see that it reacts with oxygen, excess oxygen, completely, to form what? It forms carbon dioxide and water, 4H2O. But if we want to now take a look at an incomplete combustion reaction, where there is actually insufficient oxygen, using the same example with butene, what's exactly going to be formed? Well, if we have insufficient oxygen, then what would we form? We would form carbon monoxide, guys, rather than carbon dioxide, monoxide, and water as well. 4H2O. Sorry if you can't see that clearly, that's a 4. Okay, so now in addition to carbon monoxide, carbon in the form of soot can be produced. So we could have butene react with insufficient oxygen to form carbon in the form of soot and water. It's important to know the suit can be formed because they can ask a certain question like this for your exams. So this is most likely to occur in higher alkanes with a large number. So maybe not butene. Maybe we can look at decane now, for instance. Decene, sorry. So C10H20. It would most likely react with insufficient oxygen to form soot and water. Now we'll go on to addition reactions of alkenes. But what exactly do we mean when we say addition reactions of alkenes? Well, in addition reactions, what happens is the carbon-to-carbon double bond of, let's use an example, ethene now, for instance. It's basically broken down and then turned into a single bond by an atom that comes in and reacts with the atom, right? So what usually happens is we have like a structure XY and it reacts with this ethene or alkene molecule and then it leaves it with a single bond again. And so we see structures such as hydrogen, water, or halogens that can bring about addition reactions that we're just about to see right now. Firstly, we'll look at hydrogenation. Basically, in hydrogenation, alkenes react with hydrogen to form essentially an alkane, right? And how is this achieved? So, number one, the reaction occurs at 150 degrees Celsius. Number two, a Nicholas catalyst is utilized. Okay? That's what happens. So now, hydrogenation reactions, they're actually used to manufacture margarine from vegetable oils. But this is basically how a reaction goes down. Using ethene as an example, we use ethene. We add one hydrogen molecule, which is obviously hydrogen is diatomic. And then we make use of the nickel catalyst to form ethane. So what's essentially happened in this reaction? There's a double bond here, right? Which basically hinders the carbon atoms from having that extra bond with other hydrogen atoms. So when this hydrogen atom is added to the ethane molecule, using a nickel catalyst, at 150 degrees, it's essentially breaking this double bond. And basically these two hydrogens are added. So now this double bond is broken. They have a spare bond to go by now, right? Next we look at hydration. That's essentially just a reaction with water. If you ever get confused with this kind of reaction, just think of hydration or hydro, water, or like dehydrated, now you need water. So hydration would probably be the water, right? So now, but it's not water essentially, it's steam rather. Well, water in the form of steam, whatever you want to call it. And in this case, an alcohol is formed, right? So since water is added, the molecule is obviously said to undergo a hydration reaction. And so this reaction is quite important industrially for the production of alcohols, and it occurs under the following conditions. So the temperature is going to be around about 330 degrees Celsius. The pressure would be about 60 to 70 atmospheric temperature. And now the catalyst that we'll be using today would be concentrated, or phosphoric acid catalyst. Okay, so when the reaction is complete, the reaction chamber holds unreacted ethene, ethanol, and water. The contents are then transferred to a condenser where ethene is separated easily as it has a much lower boiling point than ethanol and water. So now the different boiling points of ethanol and water and ethene, they're subjective for now. But what essentially goes on in the reaction, we use ethene as an example. We have ethene here. It's going to react with steam using that H2PO4 catalyst that we have and the other reaction conditions. So as I said, ethanol is basically the product of this reaction. Lastly, we're going to look at halogenation. That's basically the addition of a halogen to the double bond, breaking the double bond down, forming a single bond and adding halogens to it, so making a halogen alkane, right? In this addition reaction, it's done under room temperature, so I'll just write down room temp. But there's no catalyst used actually in this reaction, so that's just quite simple to remember. We add Cl to Cl. We'll kind of understand the importance of it later. It's not really for this level. GCSE is quite basic. But then we have these double bonds now, because these single bonds, because remember this double bond is broken down by this bond right here. We add the halogens here up top. And that is the product rather, dichloroethane. That's how you basically name it. And that is the end of this explanation on alkenes. If you guys are interested in joining our group GCSE or chemistry classes for organic chemistry, inorganic, or just calculation classes, please click the link in our bio and contact the number provided. Thank you.